All right, today we did area of non-right triangle and parallelograms. So first we need to go back to middle school or geometry, and we learned that the area of a triangle is 1/2 base times height, and that formula is right here. Okay. Now, that's fine and dandy when we've got right triangles for our height here, right? But, and this is our height, right? This red dotted line. But what happens when we don't have a right triangle? So we're going to be focusing mostly on triangles where we know two sides of the triangle, and we also know the angle in between. And this angle in between has a special name called the included angle. Okay, so first we're going to we're going to look at this investigation. So write an expression for the area of the triangle ABC in terms of C and H. So C is this side here, and H is the height here. So the area of this triangle is going to be 1/2 base, which is the length lowercase c, and the height, which is h. Okay, so this is 1/2 base times height, right? Okay, so now we want to write an expression of h in terms of A and angle B. So we got angle B right here. Okay, and side A is right there, and in terms of H, which is this side here. So let's pretend we're only looking at this part right here. So here we've got angle B, we've got side A, and we've got H. So the blue one is opposite of angle B, and the red side is the hypotenuse from angle B, given that this is a 90-degree angle. I'm hiding the other part of this triangle here. So this is the hypotenuse. And if I'm dealing with opposite and hypotenuse, then I'm going to need to use sine. Because sine is no good. Okay. Because sine deals with opposite over hypotenuse. So, right, it's a sine of an angle, right? So I'm going to say sine of angle B is equal to the opposite, which is h, and over hypotenuse, which is a. Now, if we're trying to get an expression for h using this, I'm going to have to multiply both sides by a. So if I multiply both sides of the equation by a, then I'm going to end up with the a is going to cancel out, and then I'm going to get h equals a times sine b. Okay, and now we're almost done, because I'm going to use this first equation here, and I'm going to substitute h with a sine b. Okay, and so I'm going to rewrite this purple equation where we get a equals 1/2 c, and now I'm going to write this a sine b substitution. Okay, so what is the relationship between the formula here and the area of a right triangle? 1/2 base times height. So basically, we used sine of the angle to represent the height. Okay. You might want to hit pause, copy this down, or move on to the next page. Okay. So here they've written all the different formulas for this, but what you really just need to know is that the focus is on, we've got two sides here, and we've got the angle in between the two, which is called the included angle. Okay. So, and so we're going to be using this for all of these problems. So, here I've got the worked out answers, so you might want to hit pause and look at this for a minute. I'm going to explain what we've written down here. So here I've got the angle using this formula. Area equals 1/2 the two sides times sine of that angle. So here we have 1/2 side 11, side 15, and then sine of 28. Okay. If I put that in my calculator, we got this. So make sure the calculator is in degree mode. Okay. If your answer is not the same as this, then you're probably in radian mode, and that needs to be changed. Okay, so here our sides are 10 and 9. Our included angle between the two sides is 40 degrees. And then here we have our two sides is 25 and 31. Our included angle is 82. Now, in this one here, it's a little different. I'll work these bottom two ones out. Okay. So, so here we've got our two angles, our two sides, but this one is x, and you're given the area is 150. So basically what we're going to be doing, okay, once again, our formula is for the area is 1/2 A and C sine B. Okay. Now our area is 150 cm squared. The length of side A is x. The length of side C is 17. And we're trying to figure out, the angle is 68. Okay, so if we're trying to solve for x, we could do a few different things. We can take this equation and we can multiply both sides by 2. And then, so I'm just going to rewrite this here. We're going to multiply both sides by 2 to make that cancel out. We're going to divide both sides by 17 to make that 17 cancel out. And we're going to divide both sides by sine 68. And that's going to give us our value for x. And after you put this into your calculator, you're going to end up with x equals 19 centimeters. Okay. Next one. Draw a parallelogram. Two adjacent sides are 4 and 6 centimeters respectively. The angle measurement is 52. So draw the picture. I saw so many students today not drawing the picture. You're going to have a lot of trouble if you try to study for the final and you don't have good drawings here. So parallelogram. These marks that I put on here meant these opposite sides are parallel. So one side is 4, another side is 6, and they've told you the included angle is 52. Now 52 is an acute angle, so I'm going to make the acute angle on my drawing 52. Acute means it's smaller than 90 degrees. On this drawing, this is bigger than 90 degrees, so I wouldn't mark that as 52 if I wanted this to be an accurate drawing. So, and then we've got the two sides, 4 and 6. Now this is a parallelogram, so it's not a triangle, but if I drew a dotted line through here, then I would have two congruent triangles. So we're going to say the area of the triangle is equal to 1/2 4 times 6 sine 52. Okay, and but we're trying to figure out the area of the parallelogram, right? So we have to multiply that by 2, right? Now, it's silly to multiply by 2 because we have this half that's just going to cancel out, right? So we do, we've got 4 times 6 sine 52. Put that into your calculator, and then you're going to get 18.9. Okay, I've got this drawing here, same sort of situation. You might want to hit pause and look at this. So we've got a rhombus. Rhombus means we have 4 sides that are the same length. We've got our angle that's 72. Just like on the other example, I drew a dotted line. These sides are 12 and 12. So we have 1/2 12 times 12 sine of 72, and you get the area of the triangle to be 68.476. Multiply that by 2 to get the area of the rhombus. I'll do the next examples in the next video.